Hi guys, welcome back to the third tutorial and good to see you again in 10 minutes for Six Sigma. My name is Jens Donath. I'm working in the global engineering in the headquarters. Enclosed you see my contact data. If you have any question or any comment, please contact me, let me know, would enjoy me. The concept of the tutorials is to explain Six Sigma and the tools of Six Sigma in special use cases. Today we want to deepen the control chart. I like the control chart very much, and out of my point of view it's a very important tool out of the Six Sigma toolbox. But I will briefly start to explain what is the project about, and that the task of this project was to bring the very sticky Aquaphor product into an aerosol can for a better application. At first I thought, cannot be, this cannot work, but it works. In a short summary is the process running in the following way. We have the cold Aquaphor and the N-butan in 3 bar roundabout. So in this both together we bring in a Hansa mixing cell where we mix this then together. The mass flow is steered so that we have under control how high is the volume or the mass flow from each product. And afterwards is again a mass flow cell. With this mass flow cell we don't measure the mass flow, we measure here the density, and this gives us information about the product which we have after the mixing cell. And then it goes into a small compensator and from there into the aerosol can. And the point is that we cannot take any sample out of the process because it's under pressure and you cannot open whatever valve to take out a sample and to evaluate is it correct. The gas is immediately gone, so you have to press everything at first into the can, and then you can measure and wait and test and whatever, but then it's already a finished product. So means it's important to have really a reliable process because you have to press everything what you make into the can. And now I want to explain a little bit the control chart and also afterwards the regression. The control chart basically is a tool to monitor the process mean and the variation. So what we see here, we know that already out of other pictures. We measure points, we measure values, and out of this we get an average. And of course we get, when we have an average and a variation, we have also a standard deviation. And the control chart calculates then out of this what we measure and where we have the standard deviation sigma, the border lines 3 times sigma, which are called upper control limit and lower control limit. So also the upper and lower control limits are defined with plus minus 3 sigma. We have here our data points, and we know already out of other pictures that we have here the normal distribution, and there we have then our sigma and also our 3 sigmas. And so we have a good overview about the process and how reliable and stable is the process. What is missing, and this we know already out of other charts and other examples, missing are the tolerances. Let's bring now also the tolerances in to the chart, and so the control chart is already done. We see here our mean, our average, we see our upper and lower control limits, plus minus 3 sigma, and we see now here our specification limits. And hopefully the picture is like we see it here, that the upper and lower control limits are in between the tolerances, and as much the distance between is, as better of course is the process and as reliable. In this picture we know also already from the CPK or CP calculation, and the operator knows where is my process and knows also when is my process running out of control. Means when the process now goes out of the upper or lower control limits, we are still in the tolerance, means the product is still okay, but the operator knows, I have to make something, otherwise I run out of the specification levels. So, and this is what we also used at the Aquaphor production, or which we still use in the Aquaphor production. Here we see a picture from the HMI, and we see here our measured values, and we see our upper and lower control limits, and we see here our tolerances. So, and looks very good. I mean the process looks quite stable. So here this was the starting point. When we start from zero, the process makes then a peak. So, but it was very fast that the process comes under control. So, and when you calculate now here the CPK, then you see that the CPK is higher than 1.33, is also higher than 2, means we are better than a 6 sigma process, means the other way around. We have here a very stable process, what of course is good. But what's that? The process is shifting. Why is it shifting? It's coming in this case from a temperature change. So we start with the propellant, which is close to the machine, and in the first couple of meters the propellant has room temperature. When this is out, we get the gas from outside, and there we have a gap from in the winter from 20 or whatever degrees, means the temperature goes down, and with the temperature also the density and everything change. So means the process is moving, and the question is now, how can we handle this? And the answer for this is we can handle this with a regression. So what is it, and what do we have to do here? We see here a graph, density over temperature. So we can measure here with different temperature the density, and we see that with a higher density also with higher temperature also the density goes up. In this case, could also go down, but however, we see that there is a relation, and that's the point, and we can put in a line here. So, and it looks like a little bit like there is a linear correlation between density and temperature. And this we made also for Aquaphor. In this case, CoLab has measured in the lab a lot, and out of this points, we made then a correlation, and out of this we got a formula. And what we see here, all the points are on a line, means also the factor, the correlation factor is very high. Also there is a very good correlation between the two values. And with this formulas which we got here, we can handle and steer the process also in different temperature ranges. So and with this we are already at the end of the small tutorial. It was a high pressure knowledge transfer, like the project also was a production under pressure, but the control chart is really a very important and good tool. And if you have any questions, if you want to know something deeper, please let me know. Contact me, ask me, give me a comment, whatever would enjoy me, and hopefully see you soon in one of the next tutorials. Thanks.